Hello students, welcome back to the classroom point. In our today's class, we shall discuss about the normality. This normality concept we also use in the redox reactions as well as in the dilution of the solutions. And one more thing is solving the questions of the pH. Particularly in the case of the pH solving questions, their concentration term used must be normality, which gives the accurate values. Even in the balancing or redox reactions or titrations also, if you use the normality, it gives the accurate values in comparison to the molarity. Molarity means you need always the balanced chemical equation for the neutralization as well as the titration. But if you use the normality, balancing chemical equation is not necessary. Now, in this normal number of gram equivalents concept is included. Regarding the number of gram equivalents, we have already made one particular lecture. Please do watch that video and come back to this class. Let's begin the class now. Normality. It is denoted by the letter capital N. So what is the meaning of normality? The number of gram equivalents of a solute dissolved in a liter of solution is called its normality. So normality means whatever the number of gram equivalents of solute is dissolved in 1 liter of the solution, that is called as the normality. Now let us see the formula to develop from this particular given definition. So normality is equals to number of gram equivalents of solute per liter of the solution. So that in the numerator write down number of gram equivalents of solute per liter of the solution. Liter means volume. So volume of the solution in liter. So this is what called as the normality formula. Here volume term is involved. So that's why this concentration term depends on the temperature. When temperature increases, volume also increases, volume of the solution also increases. As the volume of the solution increases, normality decreases because these are inversely related to each other. So that here we can write down that normality depends on temperature and it decreases by increasing the temperature. Now, what are the units of normality here? Number of gram equivalents. Number of gram equivalents means it is just a number, not the mass. That's why here we can take the gram equivalents liter is the volume of the solution. So gram equivalents per liter, or here you can write down that 1 liter equals to 1 dm cube. So gram equivalents per dm cube is also the probable unit of the normality. Now here let us try to see how to modify this formula in using the to solve the questions. So we know that number of gram equivalents is equals to weight divided by equivalent weight of the solute. Number of gram equivalents can be calculated in another formats also, but here we are taking only the mass. So here you substitute this value there, so that normality becomes now normality equals to weight by equivalent weight of solute into 1 upon volume of solution in liters. In most of the questions, sometimes volume of the solution shall be given in the liters, Sometimes they will give the volume of the solution in the milliliters. So if milliliters are given, then you have to convert them into the liters, then we have to substitute in this formula. Otherwise, directly also we can substitute. If we convert this formula into the milliliters form, we know that 1 liter is equals to 1000 ml. So that multiply this value with the 1000, so that we get normality equals to weight divided by equivalent weight into 1000 divided by volume of solution in milliliters. So this formula we can use in solving most of the questions. Let us see one example here. Find the normality of 0.49 grams of H2SO4 in 100 ml of solution. So let us solve this. Normality equals to given weight is equals to 0.49 divided by equivalent weight of sulfuric acid. So here reaction is not given. Whenever reactions are not given, we have to consider all the replaceable H plus ions of the given acid, so that its n factor value is equals to 2, and n factor value is equals to 2 means molecular mass by n factor, that gives the equivalent mass. So its equivalent mass is equals to 49 into 1000 divided by 100. So it goes 10 times and it goes 0.01 times. So that normality is equals to 10 power minus 2 into 10, that value equals to 10 power minus 1 n, or 0.1 n is the normality of this solution. So like this normality can be used. Now let us try to see the applications of normality where we can use this formula. So in that, the first one is for dilution. Interestingly, for dilution or for redox reactions, or for neutralization reactions, in all these cases, the formula is same. That is N1 V1 is equals to N2 V2. In case of dilution, N1 V1 is the initial normality and volume of the solution. N2 V2 is the normality and volume of the solution after adding some amount of the solvent. In case of redox reactions, N1 V1 is the normality and volume of one chemical component, whereas N2 V2 is the normality volume of the another chemical component. Same in the case of the neutralization also. N1 V1 could be the normality and volume of the either acid and base. If you take this side acid, here you have to take the base. So let us take some examples here. Find the normality of 100 ml of 0.1 n KOH solution when diluted to 200 ml. So what is its final solution normality? So here N1 V1 is equals to N2 V2. So initial normality of the solution is 0.1 and initial volume of the solution is equals to 100 ml, and the final volume of the solution is equals to 200 ml, and the final normality to be calculated, it goes 2 times, so that N2 value is equals to 0.1 by 2, that value is equals to, here this value we can write on 0.05 n is the normality of the final solution. Similarly here, let us take our redox reaction. Find the mass of KMnO4 required to react completely with 0.1 m of, let us take 100 ml, 100 ml of 0.1 m of FeSO4 solution in acidic medium. So let us try to solve the question here. So here we can write down that one side KMnO4 is equals to one side FeSO4. So in formula we have written that N equals to number of gram equivalents divided by volume of solution was called as the normality. So if you want the number of gram equivalents, then normality into volume of the solution. That's why every time we take the number of gram equivalent of one component equals number of gram equivalents of the another component. So here also N1V1 stands for the number of gram equivalents of the first compound and number of gram equivalents of the second compound in terms of the N2 and V2. So that number of gram equivalents I am taking here in the form of the N into N factor, that equals to N into N factor. Now here they asked about the KMnO4 mass. So number of moles means weight by molecular weight into N factor. Here number of moles of the FeSO4, but molarity is given. We know that molarity is equals to number of moles by volume of solution in liter. Then it has to be 1000 by volume of solution in milliliters. So N equals to molarity into volume of solution in milliliters divided by 1000. So this formula you take here, molarity into volume of solution in milliliters divided by 1000 into N factor. So weight of KMnO4 we don't know. Molecular mass of KMnO4 is 158. N factor of KMnO4 in acidic solution is equals to 5. Molarity value is given as 0.1 and its volume is 100 divided by 1000 into N factor of the FeSO4 on reaction with the KMnO4 is equals to 1. Then we need the weight here. So weight equals to 0.1 into 10 power 2 divided by 10 power 3 into 1 into 158 divided by 5. So here weight equals to, so this value cancel by 10 power minus 1. 10 power minus 1 is there. So 158 into 10 power minus 2 divided by 5. So it goes so 31.6 into 10 power minus 2 or else 0.316 grams. Okay. Correct. So like this we can calculate the even dilution formula for the redox reactions also. Now let us use how this can be used in the neutralization reactions. Find the volume of calcium hydroxide of 0.1 N required to completely neutralize 0.4 N and 100 ml of H2SO4 solution. So one side let us take the sulfuric acid, the other side let us take the calcium hydroxide. So I am taking it as N1 V1. This value I am considering it as a N2 and V2. Normality of the sulfuric acid is given, that is 0.4. Its volume is given 100. Normality of the calcium hydroxide is given 0.1. Volume to be calculated. So it goes simply 4 times, so that V2 equals to 400 ml. So like this we can calculate in solving the neutralization reactions also. Let us see how and in other cases where we can use this normality calculations. So second application, how to calculate volume of water added in during the dilution process. So volume of water added always can be calculated by subtracting the initial volume of the solution from the final volume of the solution. Here V2 stands for the final volume of the solution, where V1 stands for the initial volume of the solution. Similarly, we can use another formula, that is higher concentration minus lower concentration divided by lower concentration into volume of the solution. Higher normality minus lower normality divided by lower normality into volume of the solution. This is for the dilution. During dilution, how much water or how much solvent can be added, that can be calculated by using this formula. Now let us see an example here. Find the volume of H2O to be added. To convert 100 ml of 0.1 N NaOH into 0.05 N NaOH. So solution here, volume of H2O added is equals to higher concentration, that is 0.1 minus lower concentration 0.05 divided by lower concentration 0.05 into volume of solution 100 ml. So this we can write down 10 power minus 1 minus 5 into 10 power minus 2 divided by 5 into 10 power minus 2 into 100. So 5 into 10 power minus 2 we can write down as 10 power minus 1 minus of 0.5 into 10 power minus 1, 5 into 10 power minus 2 into 100. So this is 10 power minus 1 common. 1 minus 0.5 gives 0.5 again. So that 0.5 into 10 power minus 1 divided by 5 into 10 power minus 2. So it goes 0.1 times, that is 10 power minus 2, 10 power minus 2, everything cancel out. Finally is equals to 100 ml of the extra amount of the water is required to convert the 100 ml of 0.1 N NaOH into 0.05 N NaOH. The similar one also we can solve using this formula also. Then there we have to use initially N1 V1 is equals to N2 and V2. Initial normality is 0.1 into initial volume 100 ml is equals to final normality is 0.05 into final volume to be calculated. It goes 2 times here, so that volume is equals to 200 ml. This is the final volume of the solution. So volume of the water to be added is equals to 200 minus 100 initial volume, so that the answer again is equals to 100 ml. So in this way we can solve this question. Now let us see where other areas we can use this normality applications. So mixing of solutions. So for mixing of two solutions. So when solutions are mixed, then how to use this normality calculation? Here two things are there. Whether solution is having, both the solutions are having the same solute or different solute. So for same solute, let us see the first concept. If both solutions, whatever we are going to mix, if they carry the same solute, then normality is equals to N1 V1 plus N2 V2 divided by V1 plus V2 or final volume of the solution. Now let us take an example here. What is the normality of resultant solution which is obtained by mixing 100 ml 0.1 NaHCl and 50 ml 0.2 NaHCl solutions. So let us try to solve this. Final normality equals to first solution normality 0.1 and its volume N1 V1 100 plus second solution volume is 50 ml and its normality is equals to 0.2 divided by V1 plus V2. V1 is 100 ml, V2 is 50 ml. So this value is equals to 150 ml. Now normality is equals to, here the value is 10 plus here also the value is 10 divided by 150. Normality equals to 20 by 150, so that normality equals to 2 upon 15. Like this we can calculate the for mixing of the two solutions where the solute is same. Solute is same means here also HCl, here also HCl solution. Here where we can use this final volume of the solution. See, after adding this one, if the solution is made to the some other volume of the solution, then we have to use this final volume of the solution term. Let us see that question also. So the next question here is, find the normality of HCl solution obtained by mixing 100 ml of 0.1 NaHCl and 50 ml of 0.2 HCl, 0.2 NaHCl, and the solution is made up to 1 liter. So in this case, how to use this formula? So normality is equals to initial value, N1 value 0.1 into its volume 100 ml plus again second value 0.2 into its value volume 50 ml. Now we cannot take the V1 value, V1 plus V2. Why? Because even after mixing these two solutions, again some amount of water was added, so that the final solution was made up to the 1 liter. 1 liter means 1000 ml. So here we shall take the 1000 ml. So normality equals, this is 10, this is also 10, so that we get the 20 by 1000. It will cancel out, so that it is 2 into 10 power minus 2. N is the normality of the final solution. Now let us see, if the same solute is not mixed, if the solute are able to react with each other, that is acid-base reactions. So in this case, if complete neutralization takes place, then we can use the N1 V1 is equals to N2 V2. In this case, to acid and bases, they react with each other, but complete neutralization is not taking place. Then the formula is different. Now here, let us see, for solutes which react each other. So this is, let us consider it a acid-base reactions and no complete neutralization takes place. Then how to use this one? Let us take here formula N equals to final normality of the solution is equals to N1 V1 minus N2 V2 divided by V1 plus V2, or again final volume of the solution. So this N1 V1 could be the higher value, N2 V2 always shall be the lower value. So here N1 V1 higher value we have to take, whereas N2 V2 we have to take the lower value, because the concentration terms never be negative, they always positive values. Now let us see here what could be if there are conditions are there. If normality and volume of the acid is more than the normality and volume of the base, so higher value belongs to the acid and lower value belongs to the base. In such cases, the solution could be acidic in nature and pH value is less than 7. Next, if normality volume of the acid is less than the normality and volume of the base, so base value is higher, then the solution is called as the basic in nature, then pH value is greater than the 7. So if normality of the NaVa is equals to NbVb, means normality and volume of the acid is equals to normality and volume of the base, then complete neutralization takes place, so that pH is equals to 7. So for complete neutralization, this formula is not required. Already we made one formula that can be used. So now let us take an example. Find the normality of a solution which is obtained by mixing 2N200 ml of, let us take 200 ml of 0.1 N2SO4 with 100 ml of 0.1 NaOH and report the nature of the solution. So it can be solved. Here let us take the final N1 V1 values, normality and volume of the acid. Let us try to find out the normality and volume of the acid value. Normality is given as 0.1 into volume of the acid is given as the 200, so it cancel out, finally it is equals to 20 equivalents. Similarly, normality and volume of the base if you take, so normality value is given as 0.1 and volume is given as 100 ml, so final value is equals to 10. So which is higher value here? Normality and volume of the acid is more than the normality and volume of the base. So here NaVa is greater than the NbVb, so the solution is acidic in nature and pH value is less than 7. Then we have to find out the normality of the final solution that is obtained after mixing both of these solutions. So normality is equals to higher value we have to take first, so 20 minus lower value 100 and mix these two solutions. 100 plus 200 is equals to 300, so that it is equals to 10 by 300, so that it is value equals to 1 by 30 N. So like this we can use for the solutions where complete neutralization is not taking place. Apart from this, where normality can be used? Normality can be used if weight by weight percentage of the solution is given. So the formula is weight by weight percentage into density into 10 by equivalent weight of solute. What happens if weight by weight percentage is not given but weight by volume percentage is given? Then normality equals to weight by volume percentage into 10 divided by equivalent weight of the solute. So weight by weight percentage, weight by volume percentage calculations we will do in the coming classes. I hope all of you find this video informative, and please do share it with your friends. If you have any doubts, please send your doubts to the classroompoint@gmail.com, and don't forget to subscribe the channel. Thank you.